All right, 8.2, we are talking about quadratic functions again, but now we're going to talk about what vertex form means. You learned in 8.1 like what a quadratic function is and kind of the basic form, the standard form of ax squared plus bx plus c, right? So just like there's different forms of the equation for like a linear equation, remember you had slope-intercept, point slope. There's also different forms for quadratic functions for parabolas. So the one you're going to learn today is called vertex form. So you want to write that down, vertex form. So here's the one we talked about a little bit yesterday. This is standard form. Basically, it's just like polynomial standard form, right? When your exponents are in order, it goes from x squared to x, and then you just got a constant c, right? And you know it's going to be a parabola or a quadratic function when the highest exponent is a squared term. It'll always give you this parabola, okay? So now the form we're going to talk about today is vertex form. So if we look at these, here's a comparison. Here's standard form, here's vertex form. So what they've done is some factoring to get it to look like this. So I want you to write this down in your notebook. It's write the form down, right? You have a parentheses x minus h squared plus k. One thing to note is, remember we talked about this axis of symmetry. Basically, I could fold the parabola up here and it would be even Stevens right on top of each other, right? That's the axis of symmetry. So if I am looking for the axis of symmetry, it always goes through the vertex, right? The lowest or the highest point of the parabola. And you know the coordinates of this vertex, it's going to be h comma k, right? X will be h, and y will be k, and you can pull them straight from your vertex form. That's why it's helpful. If it's in vertex form, I can literally pull the numbers, the h and the k, out from the equation and know where to plot my vertex. It's a lot more helpful over standard form. So two things you should write is, one, you should write down vertex form, and two, you should write the axis of symmetry is when x equals h, and that the vertex is equal to h comma k. Okay. So you can go back and watch this if you need more time with that. So here's vertex form again. So I want you to think about this in terms of the transformations we talked about. Remember vertical and horizontal translations, like sliding the graph over to the left or the right or up and down? Those were performed by adding or subtracting numbers to a function. So really, if you look at this, h is being taken away from the x coordinate. That is a horizontal translation, right? And because it's a negative h, it means the whole vertex or the whole function is moving to the right by h, right? And this plus k, that's a vertical translation. The whole graph is moving up by k. So you could see if these were both 0, you would just have the form would be y equals a, and then you'd have 0 here, 0 there. That would be ax squared. So that's your basic formula, which we used in 8.1. But once you start performing vertical and horizontal translations, sliding it left and right, up and down, these h and k's tell you how to slide it, and that tells you where the vertex is. So you guys kind of already know this because we've talked about translations before. So now we're going to do some examples. Okay, so here's the general form for vertex form, right? They tell us that they're giving us these equations in vertex form. And they are giving us, what they really wanted you to do was they would give you this equation here, and you're supposed to graph it. So let's look. If the vertex form is x minus 1 squared, so we're going to look at this, minus 3. So I know if I look at h comma k, I'm going to get my vertex. Okay, well, h is the number that's being subtracted from x. So in my case, my h, I'll underline in blue, is 1, the number being subtracted from x. So my x coordinate on my vertex is 1. My k, my y coordinate, is going to be whatever is being added to the function? Well, -3 is being added to the function, so I know my vertex has the coordinate points of 1, -3. So if I'm plotting these, I know I could put a dot at 1, -3, and that's going to be the vertex of my parabola, and these are going to open upward. So one thing that's easy to find is that, and if you need to find other points, you would make a table. So I'm going to show you an example for this one. So if this is the function, I could say, all right, what if x is 0, and what if x is 1, and what if x is -1, right? Pick 3 points and check. Then when I plug those in, I'll get my y. So if x is 0, I'd have 0 minus 1 squared. Well, that's -1 squared. That's 1. So then I have 1, and I still have to take away 3. So that's -2. So I know that another point on this graph is 0, -2, right here. Now if I plug in +1 for x, here I put in here, 1 minus 1, well that's 0. 0 squared is 0. 0 take away 3 is -3. So my other point is 1, -3. I don't know why I did that. That's the vertex. Hopefully you caught that. I shouldn't have picked that point. And then the other point I would pick is -1. Actually, what I should pick is something to the right of the vertex. So I'm going to change this. I'm going to pick 2. So if I plug in 2, I get 2 minus 1. Well, that's 1. 1 squared is 1. 1 minus 3 is -2. Again. So now I know another point is 2, -2. And once I have those 3 points, I have enough to sketch what the parabola will look like. Let's try this one over here. We'll skip the middle one because I'm out of space, but let's look at it. So it's in vertex form. Step 1 is to find the vertex. H is the thing that's being taken away from x. Well, the thing there's nothing taken away from x, 2 is being added. So that means I have to change the sign. To get this plus here, because it's supposed to be a minus, what they did was took away a negative number. So my x coordinate is actually -2, right? It's the opposite because of this positive sign. Versus my k, my y coordinate is supposed to be a plus k. Here I have not a plus k, I have a -1. So that means my y coordinate is -1. So it's really important that you check these signs. If the signs don't match, you need to reflect it in your vertex coordinates. So I know the vertex is at -2, 1, that's here. That's the lowest point of the graph. So now let's find some other points. Let's pick a point to the left of the vertex and a point to the right of the vertex. So since x is at -2, let's pick -3 to the left, and then let's pick -1 to the right. Another easy one might be 0, because it's always easy to plug in 0 for x. But if I pick those, I'll come in here and plug it in. -3 plus 2 is -1. -1 squared is 1. 1 minus 1, because we still have this -1 here, is 0. So I know one point is -3, 1, 2, 3, 0. Then I plug in -1. -1 plus 2 is 1. 1 squared is 1. 1 minus 1 is also 0. And hopefully you start to notice these should be equal, because remember, it's symmetrical. If I fold it in half, it should be right on top of each other. So these points have to kind of have the same y value. And now I have enough points to make my graph. So now let's look at these two functions. We have g of x equals x minus 3 squared, and then f of x equals x squared. Okay, so f of x equals x squared is the most basic parabola, the most basic quadratic function. For this one, if I plug in any number, if I make a table of values, whoops, let's undo that. If I make a table of values here, and I just pick some, let's say x is -1, 0, and 1. If I plug in -1, -1 squared is 1. If I plug in 0, I get 0 squared is 0. If I plug in 1, I get 1 squared is 1. So you can start to notice that my parabola, here's -1, 1, here's +1, 1. My parabola is like that. So whenever you have the basic form x squared, your vertex is at 0, 0, right? Vertex is 0, 0. Now let's look at what happens here. Let's look at this function. So I'll make this is g of x. G of x equals x minus 3 squared, okay? So let's just make some marks here. So I can make a table of values to plot it. Actually, let's just do that. So let me pick the same points. Let me pick -1, 0, and 1. Actually, before I do that, I want to check something. Let's do this first. If I look at this equation, it's in vertex form. Here is my minus h, and there's no k. So what do I know from this? I know my vertex is hk. H is 3. There is no k. There's nothing being added because k is 0. So my vertex is at 3, 0. So I can come over 1, 2, 3, and I know this is my vertex. That's helpful because now I can pick points to the left and right of it. I can pick 2, and I'll pick 4. So if I pick 2, if I plug in 2, 2 minus 3 squared is -1. Or sorry, 2 minus 3 is -1. -1 squared is 1. Plug in 4. 4 minus 3 is 1. 1 squared is 1, which is what it should be, right? They should be the same. So I know I'm on the right track. And I have here 1 and 1. There is my new parabola. And how am I comparing them? Well, it's the same parabola, just this one, g of x, is moved over to the right 3. But guess what? That makes complete sense because this is, just like we said, this right here is just a horizontal translation to the right 3 spaces. So what I could have done is taken this graph and slid it over 3 spaces to the right, and that would have been another way to find the graph. Okay, let me see how many more slides I have here. I think I have 2 more. 2 more, yes. Okay, so now here's another one. Graph f of x equals -2x plus 1 squared plus 5. Okay, so what do I know right now? I know my vertex is h, k. So my vertex is h. Remember, it's supposed to be minus h, and it's a positive 1. So I know that it has to be the opposite sign. That's the only way I'm going from negative to positive. And then my k is plus 5. Those match. So my vertex is at -1, 5. So if I were to make my graph -1, 1, 2, 3, 4, 5, here's my vertex. Okay. Now we want to see, the one thing that makes this different is this has this -2 in front of it. So far we haven't had to deal with that. And maybe you're thinking, oh, I remember when you multiply a function, that's like a dilation. So this is either stretching it or compressing it. So let's pick some points and see. Let's pick -2, that's to the left. And let's pick 0, because that's to the right of the vertex. So what happens when we plug those in? If I plug in -2, I'm going to write down the entire equation so we can see. We'd have -2, because that's the a. Then we have -2 plus 1 squared, right? I'm just substituting in that -2 plus 5. What does that equal? Order of operations. -2 plus 1 is -1. -1 squared is 1. 1 times -2 is -2. And -2 plus 5 is 3. Okay, now let's plug in 0. This is going to be -2. Now it's just 0 plus 1 squared plus 5. So now when I add that, this is 1. 1 squared is 1. Times -2 is -2. -2 plus 5 is 3. Great. That's what it should be. It should be the same. So now let's plot those. -2, 3 is here. And 0, 3 is here. So now you can see that this parabola, I did it neatly, opens down. Why does it open down? So a note you want to take is that Let me write it down here so we can see it. This parabola opens down because A is negative. A negative A causes a reflection over the x-axis. Okay, so whenever you see, just space this out a little bit here, a negative, if your vertex form or even your standard form is starting off with a negative value, that means the thing is flipping downward. It's going to open down. It's causing a reflection over the x-axis. And then you can imagine it's flipped over the x-axis and then everything's moved to the left 1 and up 5. And that's how you end up here. Left 1 and up 5. It's got all the transformations on it. All right, last one. I know this video is getting long. So sometimes you can use vertex form to solve problems. So it says Deshaun and Chris are playing soccer. Chris takes a shot on goal. Deshaun is 3 feet in front of the goal, so here he is, and can reach the top of the 8-foot goal when standing directly beneath it. Can he block the shot from his current position without moving or jumping? Okay, so they've given us the vertex and they've given us where the ball starts. So let's start with writing our function in vertex form. F of x equals a, then it's x minus h squared. Well, what's h? H is 16. So x minus 16 squared, and then k is 11, so plus 11. So there's our vertex form. We know everything but a, so we need to solve for a. How can we solve for a? Is we can use this point. Okay, so they told us there's this point x equals 2 and y equals 1.2. So f of x is just another way to write y. So if I plug in 1.2 for y, I still don't know a. I know x has to equal 2, so 2 minus 16 squared plus 11. So now I'm just going to use my calculator to figure this out. Let's subtract 11 from both sides. Subtract 11. This goes away. 1.2 minus 11 is negative 9.8. And that equals a times, well, what's 2 minus 16? That's negative 14 squared. Negative 14 squared is 196. So I'm just going to write that down. Negative 9.8 equals 196 times a. So what's the last thing I need to do to solve for a? I need to divide by 196. This part you can totally pull your calculator out for because nobody knows this in their head. And you end up with a equals, I have it here, negative 0.05. Okay, so my equation, when I rewrite it here, is f of x equals, now I know a is negative 0.05, x minus 16 squared, and then plus 11. That's my formula, my quadratic form, or my quadratic function in vertex form. But what I need to do is actually answer the question. Can he block the shot from his current position? Okay, so he's 3 feet in front of the goal, and this thing is 8 feet high, right? They told us the goal is 8 feet high. So is he going to be able to block it? So let's see. He needs to be able to block 8 feet. So we're trying to wonder if there's a point where y equals 8. Where will he be when y equals 8? So let's see. He is 3 feet in front of the goal. So the goal is 25 feet away. So if he's 3 feet in front of it, he's at 22. He's at x equals 22. So when I plug in x equals 22, negative 0.05, then I have 22 minus 16 squared plus 11. So you'd put that all on your calculator. 22 minus 16, square it, times it by negative 0.05 and add 11. When you do that, you get f of x equals, and I'm just going to type this here, or write it here instead of solving it, it equals about 9.2. So that means at his current spot, he will, when this ball keeps going, when it reaches this spot right here, it will be at the point 22, right? Because that's the distance he's at, comma 9.2. It'll be 9.2 feet off the ground. He can only jump 8 feet up, right? He can only jump 8 feet. So is he going to be able to reach that ball that's 9.2 feet up? No, right? No, he won't reach the ball. It's higher than 8 feet. That would be how you answer it. So that's just kind of an example of how you can use quadratic formulas to solve real-world problems. These are your question problems for your homework for today. It's not too long. These 4 problems plus this set in Delta Math, which is like another 10 minutes. All right, I will see you guys next time. Bye.